Okay, so today we are going to do begin with section 4.5. The key concepts here, and it's this concept of at least one. And we have to be careful about thinking about what at least one means. And then the other key concept is conditional. Something happened, but I already have additional information. You need papers? Anybody else? I have problems in here too, Sylvia. I think. So let's talk about what at least one means. So in a situation where I'm going to be drawing from different colored marbles, the probability of drawing at least one blue. At least one blue. So that means that I could draw one blue. Could I draw two blue? Could I draw three blue? So when it says at least one, there's a lot of calculation that you need to do because I need the probability of drawing one, I need the probability of drawing two, I need the probability of drawing three, and so forth. So that's where we can come in and use the complement. So keep in mind what at least one is as we go through these examples, okay? Again, at least one is equivalent to one or more. So the complement, and remember, how do we find the complement of the event? It's what? 1 minus that probability. The opposite, correct? So the complement here is getting at least one item is that you get no items. So I would calculate the probability of getting no blues and subtracting that from 1, because that would be the complement of that probability. And that's really what it says here. The probability of getting at least one is equal to 1 minus the probability of getting none. Okay? So here we go with Topford Supplies, X Data, DVDs, and lots of 50. And they have reported a defect rate of 0.5%. So the probability of a disk being defective is 0.005. Of course, that's just taking your percent and put into your decimal. It follows that the probability of a disk being good then is 1 minus this, right? So 1 minus 0.005 is 0.995. What is the probability of getting at least one defective disk? So we could figure out the probability of getting 1, the probability of getting 2, the probability of getting 3, the probability of getting 4, and the probability of getting 5. And of course, that's going to take us a lot longer than just doing one probability. Okay? So when we do this, what is the complement? What would the complement be of getting at least one? What would be the opposite? Complement is like the opposite of getting none, right? Of getting none. Correct? So the complement is of getting none. And in this case, what would the probability, if I were to choose one disk, if I were to choose one disk, and now you got to think about it, this is where the critical thinking part and reading part of this class is. If I'm looking at the probability of not getting a defective disk, what is that probability of just one disk? Just choosing one. Yes, that means when I pick one, I'm going to pick one of the good ones, right? If it's not defective, I've got to pick one of the good disks. And we know that the probability of getting a good disk is, oops, it really does not want to cooperate. Here we go. 0.995. So the probability of getting a good disk, that means not defective, is 0.995. So I'm going to look at the complement, and I'm going to say if I were to draw 1, everybody sees where 0.995 comes from, because I want not defective. So that's that it's a good disk. How many am I drawing in this situation? I'm doing lots of 50, and I am doing the probability of getting at least one in the lot of 50, right? So what am I going to do? This is drawing 1 50 times, absolutely. Absolutely, because I'm going to look at every single disk of that 50 disk sample. So it would take us forever if we did it the opposite way. Probability getting 1, probability getting 2, probability getting 3, on up to the probability getting 50. I wouldn't want to do that. So that's why we're doing the complement. So the probability of getting none. So I'm going to write 1 minus that's the probability of getting a good disk, because I want not defective. But I'm looking at 50 of them. So I have to raise this to the 50th power. Yep, get your calculators out. Oh, I wrote it. Thank you. 995, not 955. .221? 0.222. Okay. So I think you've already subtracted from 1, correct? So tell me what this by itself was. 0.78. And of course, then that's going to be 0.222. That's my decimal, so what's my percent? .2%. Is that probability very high? It would be usual, it's in our 5% range, but if I were an engineer and I really wanted a defective disk, I'd want a better chance than that, so I'd probably look for more than 50.
How did you guys, it sounds like a silly question, but how did you get the 778? Because I got a 005. Maybe I do something incorrect both to get that. Wouldn't you go 1 and I did it both ways?
So this is the correct answer right here. What you did there is absolutely correct. So if you just wanted to do 0.995, raised to the 50th. And
that's what they got. Okay, I thought I was doing like 1 minus the not.
Yeah, I kind of put it in step order. So everybody saw where that number came from, and that's what I was subtracting from. Okay? Good. Good. So conditional probability is when an event has some additional information, such as maybe an event has already occurred, or such as maybe you're only going to be choosing from a certain portion of the sample. So I'm not going to include all the sample. And here's how we denote that. The probability of an event B occurring given that event A has already occurred. Okay? We've done similar to that before. And that is the formula. But sometimes it's easier just to look at this intuitively. So let's take a look at one that I think is much easier intuitively. The conditional probability of B given A can be found assuming that the event A has occurred and then calculating that event B will occur. So here's our good old table of these are actual tests again, whether somebody has been tested for drugs, whether they do or they don't, and then we have the false positives, the true positives, the false negatives, and true negatives. And this is where the given comes in. So this particular problem is we're going to refer to the table and we're going to find the probability that a subject actually uses drugs given that he or she had a positive test. So I'm not going to look at the whole sample now, am I? Because now I am going to be looking at the fact that I know it's given that he or she, had a positive test result, correct? Given that information, I'm only looking at that part of my table. So I want to know the probability that a subject actually does use drugs given this information. Well, how many total is in that first? 134. So out of the given group, 134, how many actually uses drugs? 44. Okay. So, somebody tell me what that is. Pretty low. 228, 328. So that's 32.8%, correct? Okay, so let me give you another one using that same chart. Given the subject does not use drugs, what is the probability that they would be tested positive? Given the subject does not use drugs, what is the probability of being tested positive? So which group am I looking at now, though? The bottom half, right? Because I already told you it's only this group. So my total in that group is how many? 950. And how many had a positive test? 90. Okay. .095. So what is that in my percentage? 9.5%. So almost a 10% chance, even though I don't use drugs, that I can be tested and get a positive result. Okay? Does the given part, is that making sense?
So when it says given, that means you have to separate it like that. Because like that,
Yes. Yes. Yes.
So if it says given, then you're just going to, certain part of the graph, not the whole, or the chart, not the whole thing.
Not the whole entire.
Some of the homework, I said I gotta do this later. I'm getting kind of frustrated because I was kind of confused a little bit.
Yeah, that's why I wanted to really take the time and talk about at least and the given part, because that's where I see students, I can see it every time taking my test. It's good, it's good, it's good, it's good, and then I get an at least or a given, and it's like falls apart. So I'm trying to really hone that in so it makes.
And at least the same?
No.
No.
Yeah, don't confuse the two. Given and at least is not the same.
Do you have an at least in here?
We'll have some at least.
Okay.
We did one at least. We did the one about the discs. That was an at least. Okay? But the given one, we'll say given, or that event A occurred, the probability of B given A. So that's the clue that I'm going to do that given part. So that's what intuitively you should do. And to me, that makes a whole lot more sense than trying to pump things through this formula. But if you use the formula, this is how it would be calculated. So in that, to me, that's more confusing. So I'm going to take 44 to find that the subject that uses drugs with a positive test out of the whole group, the subjects that are positive out of that, and guess what? Those thousands cancel. This is what we found to begin with. It just made sense. Yeah, skip all that's right. You don't have to use those long formulas. Think about it. Look at it intuitive. Circle the group to make it make sense. Okay? Here's one thing that you have to be very aware of when it says confusion of the inverse. The probability of B given A is not equal to the probability of A given B. They are never equal. Well, I shouldn't say never equal, if there might be a chance that they're equal at some part, but be careful that you don't confuse those, and you know how to read that. It means the probability of getting event A given B has occurred. The probability of event B given A has occurred. Okay? Be careful. Be sure you're reading them the same. I have an example for you on these problems. I feel positive. So I'm going to stop right there, and then you guys are going to work on your problems together in groups, and then we're going to come back together and discuss the answers to those problems, okay?